All right, so we're looking at the 2015 AB problem 1. This has to do with water flowing in and out of a pipe. So the rate, so notice they're giving us the rate, which means they're giving us the derivative, at which the rainwater flows into a drain pipe is modeled by this. So this rate is the amount into the pipe in cubic feet per hour, where T is measured in hours, between the times equals 0 to 8. The pipe is partially blocked, allowing water to drain at the other end, modeled by this, D of T, and that's the rate out. And again, they gave us the rate of both of them for all the times between 0 and 8. We know that there's 30 cubic feet currently in the pipe at time equals 0. So part A, how many cubic feet of rainwater flow into the pipe during the 8-hour period? Now they're asking about how much is flown into the pipe. We have the rate, so if you want to know how much, you're going to integrate the rate. So the amount that's in there is going to be 0, the amount has gone in there is from 0 to 8 of RIT dt. So this is the amount that passed through there in cubic feet between 0 and 8. Part B. Is the amount of water increasing or decreasing at time equals 3? Give reasons for your answer. So they're asking if the amount of water is increasing or decreasing. What they already gave us is the rates. So we're going to look at what is the rate in minus the rate out at each one of those points. And the rate in minus the rate out, if you plug those into their equations, it's negative 0.31362. This is less than or equal to 0, which means the rate in is less than the rate out. So the amount of water in the pipe is decreasing at time equals 3. It's negative, which means it's decreasing, which means R of 3 had to be less than D of 3. At what time between 0 and 8 is the amount of water at a minimum? Okay, so if we want to minimize something, remember you have to take the derivative, set it equal to 0, and find the critical points. So that's the first thing we're going to look at. The first thing we need to look at is when the rate of T is equal to the rate in is equal to the rate out. So you can do those two, set those both into your graphing calculators and look where they intersect, or you can subtract them and look for the x-intercepts. So either the intercepts of the two graphs or where the graphs intersect 0, and we get the value that it is equal at time equals 3.271658. That's just a critical point. We do not know if that's a maximum or a minimum at this point. So we need to test our values because it is a closed interval. So here's the time, here's the amount that's currently in the pipe. So we'll have 0, then we'll have the 3.2716, and then 8. We know at time 0, there is 30 cubic feet in the pipe. It told us that. In general, the amount in any given point is going to be 30 plus the integral from 0 to t of the rate in minus the rate out. So for the first one, I guess the middle one, you're going to plug in t equals 3.2716 into this value right here. When we do that, we get 27.9645. And then we'll do the same thing for the next one. We'll plug in t equals 8. And you'll get the value 48.54386. Or 3686. So it asked for which one was a minimum. So you can clearly see right now, this is the one with the smallest amount. So that's our answer. So the amount of water is a minimum at that time. And this, of course, was in hours. And then lastly, we have part D. The pipe can hold only 50 cubic feet of water. It'll begin overflowing after that. So there's a time bigger than 8, the water begins to overflow the pipe. Write, but do not solve an equation with one or more integrals that gives the value time W when the pipe will begin to overflow. Okay, again, here is our amount equation. So if we want to know when it's going to begin to overflow, that's when it's exactly equal to 50. One tiny little second above that, it's going to start overflowing. Before that, it's not going to. So 30 plus 0 to W, because that's the time they wanted you to find, the rate in minus the rate out. So how was this scored on the AP test? You got 1 point for this integral, 1 point for the answer. Part B was worth 2 points. One, that you considered the rate in and rate out, and then 1 for the answer. Part C was worth 3 points. You needed to know that you're looking for the rate in and rate out being equal to 0. You're going to write the answer, and then you're going to have the justifications. And lastly, this one's worth 2 points also, 1 for the integral and 1 for the entire equation.